Well, thank you, and good afternoon. It's a pleasure to be here. It's a pleasure to speak and talk about some of the lessons learned that I've had through a major deployment in Philadelphia, Pennsylvania, United States. When I thought about what specifically to speak about, I actually decided to draw on some material that I gave yesterday, but really looking at major topics. So first, we heard today about lots of opportunity for India and the general area as we grow into AMI deployments and more so the smart grid, and then followed by smart cities themselves. A lot of those you'll see are based on converged communications. But as we look at that, there's many system design principles that need to be accounted for. So I'll cover that and then get into system integration, the data, the analytics, and how to derive the most benefit from that. I'd be remiss if I didn't talk about governance and change management and how that will actually make the project successful, and then we'll end with a brief challenge. So the smart grid opportunity, with the deployment of an AMI platform, you can virtually monitor anything your imagine can take you to. Beyond the metering itself, you can do distribution automation, line sensors, and even going beyond into smart cities that you can do protection, police, gunshot detection, any number of different things. The real key, though, is having that strong communication network itself. So with that, I'd like to revisit this concept of converged communications. And here you have a single network that is able to serve all your different communication needs. At one point, we looked at developing very custom networks for each of the different applications, a meter reading network, a SCADA network, even voice and telemetry or communication networks. With the technology that we have available to us today, we can very easily have one network that serves all those purposes. Now, when I say one network, though, that might be a hybrid of several different types of networks. And much like the highway system, where you have your major highways, your feeder highways, and your local roads, that might be a more effective solution as you look to build smart grids out to your various municipalities and cities in their areas. So in this case, in Philadelphia, we did build a four-tiered smart grid. The first tier being a fiber optic network that reached many of our major facilities. The second tier was a wireless broadband network that helped us extend those capabilities that we had on the fiber communications out to the remaining or balance of the locations. Then we have our tier 3, which is the typical or traditional AMI type of network. We chose a wireless technology. One of the vendors here, Census Technologies, and that's worked out very well for us. Then we have the last tier, and that's probably the shortest of the distances, but that's from the meter into the premise itself and supporting solutions much like the home automation networks. So this type of approach works very well, and any of the systems that people talk about, you will have the needs to concentrate your data, backhaul that data to your head-end systems and then to your back office applications themselves. So as doing that, I wanted to mention the system design principles. Many things that you have to account for, but if you follow this guideline, you'll find it will facilitate and help deliver the benefits and success you're looking for. So things like security, making sure that you are protected, but then to the converged communications, which I just spoke to. Looking at things like interoperability, that will help facilitate the integration of many different devices. Looking at potentially privately owned communications versus publicly owned. That's a decision each of your utilities will have to make yourself. But then looking at unanalyzed or no single unanalyzed points of failure. That doesn't mean that you won't have breakdowns, that things won't break, but designing the system to be resilient against that, having self-healing systems is very important. Other factors are how you maintain and operate that system, making sure that you're building something that you can operate in an effective manner. And then lastly, adhering to defined standards. That really brings you back up to the top of the security. So you can see all these principles are very circular in nature, but very important in the overall delivery. Now, I did mention interoperability. Interoperability itself is very important. A smart grid deployment may take several years to complete. And so knowing that you select a technology that will be available throughout the deployment is very important. Technology evolves very quickly. You don't want to find that the hardware that you're putting in at the beginning of your project has become obsolete. You also want to have alternatives in the hardware itself. having multiple sources for your meters, for your other endpoints. That'll have advantages both commercially from your supply organization and also give you backups if unexpected events do occur. Now, sometimes proprietary solutions seems very attractive, but in this case, think about that. Do you put yourself in a box or a corner that will not give you the longevity that we demand with this type of solution? I mentioned data analytics, and so this is very important. It's very easy to collect a lot of data. But the problem is, if you just combine data with additional data, you still just have data. You really need to go ahead and investigate and leverage this concept of analytics that you've heard a lot today about as well. So data plus analytics becomes information, and information is the benefit that we're all looking for, learning how we can do things better, getting more information and intelligence about our customers, about our grid, about our assets, and so we can operate them at the best way possible. Now, I mentioned I'd talk a little bit about the program structure. We spent a lot of time today talking about hardware, about technology, what to buy, how to put it in. But I think it's very important to look at how you're going to operate that technology. Look at the governance models that you're dealing with. I found in my experiences that there's 3 major organizations within your company that directly deal with the smart grid. Now, you might have different names for those organizations, but they really fall into the customer operations or billing areas, the engineering or technical services areas, and then the information technology area. Each of these organizations have very significant roles in the operation of the smart grid, much like a 3-legged stool that I have illustrated here. If one area has more power, more bias, more influence, the stool will tip. It will become unstable. It'll fall. So looking for a governance structure that balances all those. This involves setting real expectations of the different stakeholders in the program itself. And then, as I mentioned before, the change management element. Just rolling out the technology is only half the solution. You need to roll it out, you need to train it, you need to set your expectations, and you need to be able to deliver on the benefits that you've defined. That includes the training element. So lastly, the challenge is now as the grids are evolving, we're evolving from that 20th century grid to a 21st, maybe even a 22nd century grid. We're going from manual controlled endpoints to automated. We're going to self-healing networks. We're going to automation and a number of different solutions. So I've always felt this slide really summarizes in many ways where we're looking to go in the smart grid itself. So again, thank you for this opportunity, and I look forward to learning from you as you deploy your smart grids. Thank you.
I'm going to ask one question of you and everyone, and in the meanwhile, invite Bernard Lessus to start loading the slides. So meanwhile, this journey of smart grids, and this is a question for everyone, how long has it taken? Because everyone's in a hurry in India that we're trying to do, but there's a reality check, so this is just an open question.
Well, that question comes up often for me, and for myself, for my company, we've been on this journey for many, many years. In other presentations, I said this can take 20 years. It can take quite a long time, but it really is an evolution. So the latest step or the latest leg of that journey itself, you might call it the AMI leg of that journey. We've been doing AMI probably for 5, 6, 7 years now, and there's several steps of that. So developing the infrastructure, the information technology, the applications. There's installing the communication grid, and then, of course, installing the endpoints. Each needs to be done. You can parallel some of those efforts, but I've seen many projects fail because they do them too quickly. And a lot of that goes back to the change management, making sure the organization is really ready to adopt and use this new hardware.
Thank you.
Thank you.